All right, today we're looking at the notes for what is the standard form of any quadratic. This foldable will fold up like this. Make sure when you finish it, it gets folded and glued into your journal. So the first thing we want to identify with standard form, this a value, when a is positive or when a is greater than 0, it's going to open up. So your parabola is going to open up. When your a value is less than 0, your parabola is going to open down. It will also tell you how wide or how narrow it is. If the value is close to 0, so something like 1/2, it's going to be wider. If it is a larger value, a value away from 0, such as, I don't know, 12, it's going to be more narrow. Just like in vertex form, this value that gets added on at the end, this is actually going to be our y-intercept. So your y-intercept is always your c value, so it's just whatever number is out here, which makes sense because in order for it to be a y-intercept, the x values have to be 0. And so if the x values are 0, there's only one thing that's left, and that's that c value. Your axis of symmetry, to find your axis of symmetry and to find your vertex, we can use this formula, which is negative b over 2a. Your a value is going to come from here. Your b value is going to come from here. The biggest thing that we make mistakes on is this right here. Make sure that you identify that it's negative and you're taking the opposite value of b. Whenever we want to find the vertex, once we identify this, we're identifying our x value for our axis of symmetry and our x value for our vertex. So we'll substitute this x value into our equation to find y, which will give us our vertex. Remember, you can always double check these whenever you graph these on Desmos. So let's go ahead and start with problem number 1. Problem number 1 reads f of x equals negative x squared plus 4x minus 2. The first thing I'd like you to write down is the same thing we did in our last unit. Identify your a, b, and c. Our a value is negative 1. Our b value is 4. And our c value is negative 2. For our axis of symmetry, we're only concerned about our a value and our b value. So what I like to do is I like to make the top value negative, the b value negative, and I substitute in for b what my b value is. So in this problem, b is 4 over 2, and my a value, which is negative 1. Let's go ahead and do some arithmetic. This on top becomes negative 4. This on bottom, 2 times negative 1 becomes negative 2. A negative divided by a negative is going to make a positive, and 4 divided by 2 is going to be 2. This gives me my axis of symmetry, which is x equals 2. Now, because I know that, I can go ahead and use that to find my vertex. I know for my vertex, my x value is going to be 2 because that's my axis of symmetry. That's the whole point of doing this, is to find our x value for our vertex. I don't know what the y value is, but I know I can substitute in my x value. I can substitute 2 in because that is the vertex, the x value at the vertex. Now let's go ahead and do the arithmetic. we do exponents before we do multiplication. So 2 squared is 4. So this becomes negative 4. Plus 2 times 4 is 8. And then at the end, minus 2. If I start at negative 4, I add 8. I subtract 2. I will end at 2. So my vertex is the point 2, 2. So to recap, I use this formula. I identify my A, B, and C. I use this formula using A and B, substitute it in, do the arithmetic to identify my X value and my line of symmetry. Knowing that X value allows me to input 2 and this X value into the formula to get my Y value for my vertex. Now on to the Y-intercept. The Y-intercept is just my C value, so negative 2. At the Y-intercept, the X value is always 0. And the Y-intercept in this problem is negative 2 because C is negative 2. I'm also going to write the vertex right here. That way I keep track of it. So my vertex is at 2, 2. Looks like it's that dot right there. My Y-intercept is 0, negative 2, which looks like it's roughly right there. And this is a parabola. My A value is negative, and the rule is if my A value is less than 0, so if it's negative, it opens downward, which makes sense because my vertex is above my Y-intercept. So I'm going to make a parabola, which is a U shape, so slight U and go down. We are only halfway done, though, because we have the other side. And whatever happens to one side happens to the other side. Because this point exists here, I know there is a matching point on the other side at 4, negative 2. Because of the line of symmetry. A parabola will have the same thing on either side. And as long as I have that vertex point and one other point, I can make my parabola. We talked a little bit about this in the warm-up. Your domain value. Every x can go into this problem. It does not matter. You can use any x that you want. You can use any real number. So the domain is all real numbers. This will be true as long as there's no restrictions put on the function. A restriction could be something along the lines of someone hitting a baseball, right? So you can't go into the negative if someone hits a baseball. Range. Your range value is always your Y value. You look for your maximum or minimum point at your vertex right here, which is 2. And based on the graph, you decide whether or not it's everything above the vertex value or everything below. This is going down. So you want all the Y values less than or equal to 2. I'd like you to pause the video and work as far ahead as you can on problem number 2 and come back to whenever you get stuck. On problem number 2, you always want to start with your ABC. If you're stuck at this point, follow along. Your A value is 1. Your B value is negative 4. Your C value is negative 5. Your axis of symmetry formula states that x is equal to negative b over 2a. My b value is already negative. Make sure that whenever you do substitution, you substitute in with a parenthesis. 2, and then my A value is 1. Go ahead and calculate this out to find your axis of symmetry. What you should have done is this on top should become positive. 2 times 1 is 2. 4 divided by 2 is 2. So your axis of symmetry, just like the last problem, also happens to be x equals 2. So therefore, your vertex value is 2. To find your y value, you take your function f of x equals x squared minus 4x minus 5. You substitute in, instead of x, you are going to write 2 because that is my x value. And remember, whenever you substitute in, always use parentheses. That way you won't make little mistakes like the negative up here. That's why we always use parentheses. Okay? 2 squared is 4. Negative 4 times 2 is negative 8. Minus 5. 4 minus 8 minus 5 is negative 9. So my y value at my vertex is negative 9. If you would, go ahead and plot that point, identify your y-intercept, and plot your y-intercept. Your y-intercept is always 0 and your c value. In this problem, your c value is negative 5. So your y-intercept is 0 and negative 5. So your point should be there. Your a value is positive 1. So therefore, because it's positive, it should open up, which it looks like it is doing because your vertex is below your y-intercept. So go ahead and draw 1/2 of your parabola. Remember, there is an axis of symmetry that runs right here. So this point's going to have a friend on the other side. It's going to be at 4, 5. And that's going to go up. Again, let's identify our domain and range. We may not be asked to do this on the homework or assignments or anything like that, but it's going to be in a good habit because we are going to be asked it later. Our domain, there are no restrictions on this function at all. And what I mean by restrictions is if there's some sort of real life problem, okay, there are no restrictions on this, so we can use any x value we want. Plus, we have these arrows, which means it goes on forever in this upward and right direction and this upward and left direction. So that means it is all real numbers. Again, your domain will often be that unless there is some sort of restriction. Range will naturally have a restriction because of it's a parabola and it's squaring. Range is always tied to your y value, and it's always tied to the y value at the vertex, which in this case is negative 9. And so you have to look at the graph and do you want the values above negative 9 or below negative 9? And we have the graph going above it. So all the y values that are greater than or equal to negative 9. Again, here are the notes for today's lesson. Make sure that these get folded up, glued into your journal. Use them to help you out with today's assignment. Everybody have a great, wonderful day. Stay out of trouble. Make good choices. Be good people.